Hello and welcome. My name is Caio, I'm an engineer with Typhoon Hill, and together, let's walk through some of the exciting new features of the Typhoon Hill Control Center 2024.1 software release. Before we get started with this video, we are thrilled to announce some exciting new upgrades focused on electric vehicles charging controllers, including two new components, the ISO 15118-20 EVCC and the CHAdeMO EVCC components. We will cover both of these components in detail in our next video, which will be linked in the description below. Now let's dive into the other new features for this release. We are glad to introduce a new component to our library, the DC Constant Power Load. With this component, our goal is to simplify the integration of DC constant power sources and loads into our models, making it especially beneficial for applications such as DC microgrids, electric railways, and many more. This component can be found in Library Explorer under the Sources folder. For demonstration purposes, let's connect it to a voltage source and measure the current flow with this current measurement component. This component was designed using a current source, and it can operate as either a power source or a power load. Upon opening its mask, you see that it has current limiting capability, which is currently set to 100 amps in any direction. There are two options for setting the power reference: the SCADA input or via signal input. Opting for signal input adds the PREF input to the component, allowing you to feed in a reference signal. This signal can be derived from your model, such as from signal processing logic. Opting for a SCADA input lets you set the power reference directly via the SCADA panel. We've prepared an example demonstrating one way of doing this. Here you can see that altering the power reference while keeping the input voltage constant results in a corresponding changes in current flow. However, with our current limit set at 100 amps, any further increase in power reference magnitude doesn't impact the current. Lastly, the Snubber tab lets you specify the snubber resistance, connected in parallel with the component's current source. With the 2024.1 software release, you can now define your own simulation step. To demonstrate the advantages of this improvement, let's use the IEEE 13-node test feeder that can be found in our Examples Explorer. By opening Model Settings and navigating to the Circuit Solver Settings tab, you'll notice that a simulation step of 2 microseconds is pre-selected. Prior to this update, our options were limited to a predefined list, which for Hill 606 ranged from 200 nanoseconds to 20 microseconds. Compiling this model with a 2 microsecond simulation step results in a time slot utilization of 50.71% for Core 0. Now let's revisit the model settings. By reducing the simulation step to 1 microsecond and recompiling the model, we observe that Core 0 presents timing constraints. While it's possible to partition the circuit across different cores to maintain the lower simulation step, this new feature allows you to, for example, specify an intermediate simulation step between 1 and 2 microseconds. This gives you better flexibility over your hardware utilization without necessitating the partitioning of the circuit into different cores. Before editing the simulation step, the only thing to keep in mind is that the simulation step must be in a range between 200 nanoseconds and 20 microseconds for this Hill device. It must be an integer multiple of 50 nanoseconds. If you do not follow these requirements, you will receive a validation error message. For example, by selecting a time step of 1.25 microseconds and recompiling the model demonstrates that the time slot utilization for Core 0 is now 81.14%, and the model compiles successfully. Our goal with this new feature is to give you the option to select the precise simulation step that is most suitable for your model, helping you better manage your hardware resources and perhaps even enhance your simulation fidelity. We are happy to bring even more improvements to the Hill Connect interface. We have already covered the basics of these components in the 2023.3 software release walkthrough. We've also left a link for it in the video's description below. In this update, we've introduced a new configuration preset, along with expanded support for various hardware cards tailored for battery management systems, or BMS. For those specializing in battery management systems, we offer a ready-to-use BMS interface. This hardware interface can now be easily configured in just a few steps through our software, thanks to the new improvements in the Hue Connect interface component. By selecting the new BMS configuration and applying the changes, each slot is automatically updated to reflect the designed arrangement of cards for the BMS interface. In simpler terms, when you employ the ready-to-use BMS interface and select the corresponding configuration preset, manual selection of cards of each slot becomes unnecessary. The system automates this process for you. For example, slots A, B, C, and D contain a cell simulator card, slot E contains a CAN resistor emulator card, slot F is equipped with a BMS digital card, and slot G with a BMS analog output card. This update is part of our commitment to providing comprehensive hardware and software support for BMS applications, with the aim of ensuring seamless integration with your BMS under test. In our last release, we introduced a demo version of Ethernet IP, and now we are excited to announce that we are offering full support for Ethernet IP server, which includes the support for implicit message transfer and explicit message transfer. The Ethernet IP server component can be found in Library Explorer by navigating to the Communication folder under the CIP folder. Notice that, different from the demo version introduced previously, you can now freely choose an EDS file, and by doing so, the file will be parsed and all relevant information will be shown in an organized manner for you. For instance, let us parse an EDS example file provided by a manufacturer. Notice that these three tabs appear: the Classes tab, the File Information tab, and the Device Information tab. The Classes tab is essential for device configuration. Here you can access the list of parameters and assembly classes, along with their instances and the full array of attributes as defined in the EDS file. The Model Control column defines if the value for a specific object will be controlled using the signal from the model. If this field is enabled, you can select the direction of this information exchange, and a terminal is created on the component that can be used to connect any signal processing signal to that object. Depending on the choice from the terminal type column, a port appears as an input or output terminal on the component. It's important to know that for Hue devices with multiple Ethernet ports, Ethernet IP communication is realized through Ethernet port 1. We hope that with flexible parsing of EDS files and support for both implicit and explicit message transfer, you can now test with more devices and have the advanced customization and control options you need for your tests. Now let's boost the flexibility of the OPC UA server component by enabling Ethernet port selection. Some of you expressed interest in simulating various communication protocols within a single model across different networks. To achieve this, 4th generation devices now let you select the Ethernet port when configuring the OPC UA server component properties. The OPC UA server component can be found in our Library Explorer in the OPC subfolder of the Communication folder. In this demonstration, I'm using a Hue 606 device, which contains 4 Ethernet ports, so as a result, you notice 4 selectable port options in the drop-down list. With this enhancement, you can now simultaneously implement various communication protocols within the same model across distinct networks, expanding the possibilities of using the Hue device as a gateway. We are happy to have you join us for this comprehensive walkthrough. Remember, your feedback propels our passion. We encourage you to explore these upgrades in your project and don't hesitate to reach out with your thoughts. For more information and updates, stay tuned. Thanks for watching.
Check the video description for more resources on this topic, including how to download and get started with Typhoon Hill Control Center for free. You can also visit Hill.Academy to access free courses, expand your Hill testing skill set, and get certified. Subscribe to our channel to get notified about new content.